And the next topic in electromagnetic induction chapter is magnetic flux. The magnetic flux is defined as the number of magnetic lines passing through a given conductor. It is denoted by phi b. To understand this, for example, take a magnet. It has some magnetic field. The magnetic lines of force are shown here for this magnet. If the magnetic lines are more, then the effect of magnetic field is high. Similarly, if the magnetic lines are less, then the effect of magnetic will be less. Now, let's take a rectangular conductor plate as shown here and place it beside this magnet. The number of magnetic lines passing through this plate is called magnetic flux. If the magnetic field line increases, then the magnetic flux through the plate is also increases. Similarly, if the magnetic field lines decreases, then the magnetic flux also decreases through the plate. We can say this as the magnetic flux is directly proportional to the number of field lines passing through the surface. It is given by phi b is directly proportional to b. Here, b means power of magnetic field or the number of lines passing through the conductor plate. Let's say this as equation 1. Similarly, if the area of conductor plate in the magnetic field increases, then the magnetic flux through the plate also increases because more number of lines can pass through it. Similarly, if the area of conductor plate decreases, then the magnetic flux through the plate also decreases because here the less number of lines can pass through it. It is given by phi b is directly proportional to area. Let's say this as equation 2. In the above equation, A is the area of conductor plate. From the above two equations, we can write it as phi b equals to dA into cos theta because from the both equations we got LHS common. Here from the above expression, theta means the angle made by conductor plate with respect to its magnetic field as shown here. If the plate is perpendicular, then theta will be 0 degrees and the expression becomes phi b equals to dA into cos 0. We know that cos 0 is 1. We will substitute this in the above equation. Then it will be phi b equals to dA into 1. That equals to b into a, which is maximum. It means the maximum number of lines will pass through the rectangular plate when the plate is placed perpendicular to the magnetic field. It means magnetic flux through the plate is high at this case. Now place the same rectangular plate in parallel to the magnetic field, which makes 90 degrees angle as shown here. Then the expression becomes phi b equals to dA into cos theta, where theta is 90 degrees because it is in parallel position. So substitute 90 in the place of theta. So the expression becomes phi b equals to dA cos 90. You know cos 90 is 0. So phi b equals to dA into 0. We know that anything is multiplied by 0 will become 0. So the phi b equals to 0, which is minimum. It means no magnetic lines will pass through the rectangular plate when the plate is placed parallel to the magnetic field. It means here the magnetic flux is 0. From this, we have to understand that magnetic flux means the number of magnetic field lines passing through a conductor plate which is placed in a magnetic field. The magnetic flux changes by changing the area or the power of magnetic field or the angle of conductor plate with respect to the magnetic field. This is magnetic flux topic.